Assalamualaikum and hi. So today we will present to you our case study experiment 5 gas chromatography. Next, I will continue with the introduction. The term gas chromatography refers to chromatographic techniques that separate components based on their volatilities, implementing gas as a mobile phase that carries samples to solid or liquid stationary phases. There are two types of gas chromatography, which are gas-liquid chromatography and gas-solid chromatography. Besides, the principle of gas chromatography is, as the sample solution comes into contact with the second solid or liquid phase, the solutes will begin to interact with the other phases. Due to the different absorption rates, ion exchanges, partitioning and sizes, the interactions will vary and allow the separation of the mixed components from each other. These differences will cause the mixture to pass through the column at different rates and the compounds can be separated. Gas chromatography have many types of detectors such as flame ionization detector (FID), thermal conductivity detector (TCD), flame photometric detector (FPD), electron capture detector (ECD), and mass spectrometer. However, FID instrument had been used to carry out this experiment as it can be used in mostly every organic and responsive for parts per billion analysis.
Hi and Assalamualaikum. My name is Aisyah binti Muhammad Isham. I will present about procedure in experiment 5 of gas chromatography. Procedure for gas chromatography. This experiment have three parts of procedure. The first we label it as we label it as ABC. The first we label is as part A, which is sample handling. Firstly, we need shrink the rinse before filling with the sample. The shrink was make sure no air bubble. If have air bubbles, the shrink was tapped gently to remove the bubble. The shrink was hold vertically needle up and push the plunger to the required volume at eye level. The excess was removed using a tissue. Next part B, we have experimental. This is about instrument GC. The instrument which is GC was switched on. The GC was set with a condition in initial oven temperature 70 Celsius, final oven temperature 70 Celsius, and injection 180 Celsius, and also the detector temperature 180 Celsius. After that, the component sample was injected and each of the component was determined by their rotation time individually. The standard meter was injected and each component were identified by comparing their rotation time of each component. The unknown sample was injected and the component present in the unknown was found. Next, we go to the column temperature. We need to set it in the initial column temperature with 100 Celsius, the final column temperature 100 Celsius, and also the standard mixture and the effect of reducing the temperature on the rotation time and R of the component were commented on. Next, we set the oven temperature were changed and the initial oven 150 Celsius, final oven temperature 150 Celsius, and also the standard mixture was injected and the effect of the increasing temperature on the rotation time and are were commented on. So next, we have part C, which is operation of TC. So firstly, for manual injection, the sample was injected into the septa liner. The oven column was checked. The instrument was on mode off. The instrument switched on the warning tone. On the warning tone will ring if the gas is not enough. The instrument 1 online was clicked. The instrument was set up itself after the setup finish or complete. The method and the entire method were clicked. We need to enter the title and click OK. Next, the menu was clicked to select injection and back was clicked to select location. If the sample have a high concentration, we need to choose split mode. If the sample have low concentration or in a small quantity, we need to choose splitless in inlet. column section no 2 was choose. At inlet column choose back. At mode column choose constant pressure. At outlet column choose ambient. The FID was used. The parameter was injected. Lastly, OK. Click apply OK, signal detail, and then go to the OK, and then edit integration events, and then OK, specific report, and then we go to OK, and runtime checklist, and then OK. Then we need to go to the file, click method. During the injection, make sure no bubbles appear in the string. Run control was choose and click the sample info to set name in the operator name. The signal 2 was set, the run method was clicked, and the instrument will wait for injection. Inject the sample. We need to inject the sample quickly and press start button quickly on the instrument. Then, quickly pull out the string from the spectra liner. Go to data analysis, click file, and then load signal. We need to enter the calibration, and then we need to click new calibration table, enter our name, and then print the document. For the next sample, we need to click data analysis and repeat step 70 until 21.
Assalamualaikum, and now I am going to continue on the presentation with the data analysis. So as we can see, this is diagram 1 to 3 is the graph for each of the substance that we use in gas chromatography. First up, the first diagram is the data we collected for each temperature for standard mixture. Diagram 2 is from N-butanol, and the third diagram is from 2-propanol. Next is our analysis. So in the table shows the data that we collected from the data we collected, which is the retention time for each of these compounds at the temperature given. So from my analysis at 70 degrees Celsius, the peak for the standard mixture are fully resolved, which is very accurate at first. Second one, for 2-propanol, we see that the peaks are very closely packed together, very broad but not fully resolved. And next will be the 2-propanol. We see that the peaks are not fully resolved except for 1.448 and 1.59, which is not fully resolved. And then we have 1.68 and 1.67 retention time, which they are fully resolved at 70 degrees Celsius. Next is 160 degrees Celsius. For standard mixture, the retention time for 1.33 and 1.45 is fully resolved, which is very it shows that it's very accurate. While at 1.52 and 1.54 it's not fully resolved for the at 100 degrees Celsius. For N-butanol, the is shows the same result from except for one particular retention except for 1.5 1.45 2.12 and 3.00 are fully resolved. However, as I said before, at 1.52 and 1.55 is not fully resolved. For 2-propanol, all of the peaks from the graph are very tightly packed together, but it is not fully resolved. At 140 degrees Celsius, all of the peaks for standard measures are fully resolved. At 140, all peaks obtained are fully resolved for the standard mixture and the N-butanol compound. However, only 2 peaks are showed up in our graph.
Hello, my name is Nurhani binti Abdul. I will continue for the conclusion of the experiment 5. The first objective of the experiment is to determine the retention times of N-butanol and 2-propanol. The second one is to identify the components that present in a standard mixture based on the time retention. The third one is to identify the components that present in an unknown sample. The last one is to determine the effect of temperature on Tc and Rs. The advantages of gas chromatograph are it is high resolution, very good separation and have very high sensitivity. The limitation of gas chromatography are sample must be volatile and the thin sample choke the capillary.